Welcome back to our polynomial flip book. We are on page 15, and we are going to start doing a little bit more challenging stuff in this flip book, and I'm excited about it, and I hope you are too. So we spent the first half of the book just kind of learning about polynomials and how to do some simple operations on them. Now we're really going to start doing a little bit more challenging stuff. We're talking about factoring here, and we started with, in our last video, we talked about factoring out a GCF out of a polynomial or a binomial, and this time we're going to take that idea a step further, and this is all, we're just going to start putting some tools in our toolbox. We're working on factoring tools right now, and the whole idea is, and we're going to see it again on the bottom of this page, the whole idea is to be able to apply the zero product property and be able to solve these equations that have x squareds in them that are quadratic, okay? And we see quadratic things and even bigger things than quadratic. We see polynomials in many different forms. So in certain forms, like last lesson, we were able to just factor out a greatest common factor, and we were like, cool. That's all we had to do, but sometimes they're a lot more complicated than that. So we are going to look at factoring by grouping today. I already wrote down the steps for this for us to save us a little bit of time. The first step is to group the first two and last two terms. I'll show you what that means in a second. Step 2 is to factor the greatest common factor from each binomial. Step 3 is we're going to rewrite using the distributive property. Okay, so let's look at what that looks like. So we're going to factor the first two, or group the first two and the last two terms. That's why that's called factoring by grouping. Okay, so I'm going to draw an arrow. We're gonna set aside this, and we're going to set aside this. Okay, so this is going to be G times AB minus 8A plus 15B minus 20. All we did was we grouped it. We said, give me those first two binomials and give me those second two binomials. Now this is where it's really, really important that you understand how to write our binomials, our polynomials in our in the correct form, from biggest degree to smallest degree, right? Because if they're not from biggest to smallest degree, this is not going to work. Okay, but this is a degree 2, a degree 1, and a degree nothing. So now we're on to step 2. We've grouped it. That was really easy. We just drew parentheses around stuff. Now we are going to factor out the greatest common factor from each binomial. Well, that was the last lesson, right? I'm just going to look at each of these two terms. And I'm going to see what they have in common. Well, this is divisible by 2, and so is this. So I'm going to factor out a 2. Oops, and I'm going to factor out an A. Boop. A 2 and an A, because these both have an A in common. This doesn't have a B over here, so I can't pull out a B. Okay, well, 6 divided by 2 is 3. A divided by A, well, those cancel out. B divided by nothing is B. 8 divided by 2 is 4. And A divided by A is 1, or those cancel out. And that's what I'm left with. And it should usually look like this. I have one term that has a variable in it and one term that does not. Plus, let's do this. Well, these both can be divided by 5, and I'm left with 3b minus 4. Holy moly, do you see it? I hope you do, because I see it. Okay, we are going to rewrite using the distributive property. Well, let's remind ourselves what the distributive property is. A times B plus C equals A times B plus A times C. So the question is, what form are we in right now? Well, right now we're in this form. Do you see this plus sign right here? So we've got one term here and one term here. The silly thing is it's written backwards. This is really written as like B and A and C and A. But this is exactly the same. Do you see it? 3B minus 4 and 3B minus 4. That is exactly the same. So, and this is going to happen always when we factor by grouping. It's just a beautiful thing. A beautiful thing. And you'll start to see why as we move through this a little bit more. But right now I want you to see the distributive property here, okay? I've got A times B. I'll put these in little quotations so you don't get confused about what those are. And I've got A times C. Oh, that is so exciting. So you're telling me that if I have the same A, that I can rewrite this thing like this. And I'm telling you, yes, you can. And that's so exciting. So we are going to have, now it doesn't matter what order you put this in. I'll pull the A's out front since we have it down here like this. I've got this 3B minus 4. And then what do? Well, I say A, or I say B plus C, right? B plus C goes in my parentheses here, right? So here's my A stuff, and here's my B plus C. So B is 2A plus 5. You could also think about, here's what I have in common, and here's what's left over, okay? So, and let's look at this. Here's my A. Here's my B plus my C. That is some beautiful stuff, right? Okay, so we are going to use that idea a lot. That is such an important concept for us. So let's try it a couple times. If you want to pause and try this on your own, go for it. I'm going to cheat, and I'm just going to say, first step done. Check. We're moving on to the second step. Second step is to factor out the GCF from each binomial. Okay, we can do that. These both have a 3 in common. Agreed? That's their GCF. Okay, so I've got a 3. These both have a D in common. This doesn't have an E, so I can't pull out an E. So we're going to just have to leave it at that. 9 divided by 3 is 3. D squared divided by D is a plain old D minus, well, 3D, that obviously cancels out, and I'm left with an E here. Plus, now I'm forgetting this was over here, and I'm just looking at this, okay? 6D minus 2E. Well, they both don't have D's, they both don't have E's, but they both have a 2, don't they? 6 divided by 2 is 3, and that D is still left over. Minus 2 divided by 2 is 1, and that E is just left over. There it is. There's my A. Do you see it? A, the thing they have in common. Ooh, quick, before we forget what we're doing, let's pull that out. We pull it out. There's our A. Okay, now we just need to find a B plus C. Okay, we can do that. Here's a B right there. Plus C. We have done it. Yes. Okay, let's try another one. Quick, put your parentheses down. Whew, we did it. Okay, now we've put our parentheses down. Let's factor out our GCF. Here we go. I have a 5 that these both have in common. Ooh, x to the 3rd. Well, that's fun. X to the 3rd. I did it again. I squished myself. Well, 5 divided by 5 is 1. X to the 4th divided by x to the 3rd. Well, that's just a plain old x. Minus 3 x to the 3rd divided by x to the 3rd. Well, that is nothing. Minus, oh my goodness. Well, you know, this is kind of difficult, but I want this to look like this, right? I want this to look like this. Okay, so in order to do that, I am going to actually distribute up here. Because really, and we've talked about this a million times, this is a negative and a negative. That's not true. I'm putting my parentheses around this guy. Let me rewrite that. So what we had here is, instead of putting my parentheses right here, I'm going to call this plus a negative x plus 3. I shouldn't have done this. That was bad. Okay, so if I've got this, how do we get from here to here? Well, I'm going to pull out a negative. And what is going to happen when I pull out that negative? Well, this is going to become a positive sign. And then I'll have x minus 3. Basically, I've changed both of the signs here to give me exactly what I wanted. Okay, let's make sure that this is a true statement now. Yeah, golden. Okay, so now that we've done that, let's do our final grouping. I see an A, so let's pull that out. And I see a B. Ooh. Does that help if I put a 1 there? You can do that. You know 1 times anything is that anything. So we can always put a 1 in front of something if we need to. Because we definitely need a B, right? Let's check to make sure we get the right thing. If I do negative 3 times 1, I end up with negative 3. You know, I didn't do it right. This should have stayed a negative right here. That is my fault, my friends. I am rusty because I want this to be negative 3 times negative 1 gives me a positive 3. A negative 1 times x gives me that negative x I was looking for. Negative 3 times 5x to the third gives me that negative 15x to the third. And x times 5x to the third gives me that 5x to the fourth. We'll do some more examples like this together so I can clear that up for you, because I obviously made a silly mistake on this very first one. I'm just gonna the very first one of this year, because I think that idea is just a little bit confusing. But we're going to get that figured out. Yeah. Okay. So let's move on to our next one. And like I said, we'll do some more examples like this one to clear that up a little bit together. Oh, I'm so excited. Example number 2. Guess who's back? The zero product property. Yay! Smiley face. Okay, this is the whole point. We're working on building tools that allow us to use the zero product property. Today's tool was factoring by grouping. Now let's use it, okay? So the whole idea is that if I can factor this thing by grouping, then I will be able to solve this equation and all will be right with the world. So let's try it. And a side note, the zero product property is kind of a chapter 9 thing, but we're just getting some like extra practice in on it. Of course, I'm going to quiz you over it. We're just getting some extra practice on it right now. So by the time we get to chapter 9 and we make it a little bit more difficult, then we'll just be really, really good at it already. Okay. So step 1, we're obviously doing factoring by grouping. Factoring by grouping. Okay. So I'm going to put this in parentheses and this in parentheses. Step 1 complete. Step 2, find a GCF. Well, I see 2 and I see an x. So I have 2x and what's left in here, an x minus 4. We need to do the same thing over here. I see a 3 and a 3. That's all I can factor out. And I end up with x minus 4. Oh, this is so exciting. Do you see it? Do you see A? Well, okay, let's apply A now. Oops. x minus 4, that is a 4, believe me, and 2x plus 3 still equals 0. So now remember that if I have a times b, if I have this times this, well, one of these has to equal 0 in order for this to be a true statement. Meaning, if I find the values of x that make this 0 and the value of x that makes this 0, I will have found the solutions to this equation. Okay, so we're going to say, well, I need to make this equal 0, or I need to make this equal 0. So obviously, to solve this, I need to add 4 to both sides, and I get x equals 4. There's my first solution. Obviously, to solve this, I need to subtract 3 from both sides and divide by 2, and I get x equals negative 3 halves. Feel free to show your work there if you need to, okay? Next one. Feel free to pause if you're feeling good about this and want to try it on your own and just make sure you're doing it right. You'll notice a theme here. We're going to end up with stuff that looks like this. We're kind of jumping the gun a little bit on what our next lesson is going to show us how to do, because we're basically going to do one more step to get it in this form, and then we're going to use this form to finish our process. Okay, so I see that these are both divisible by 2 and y. So I end up with 5y minus 3. And I see that both of these are divisible by, what are those divisible by? 3, 7. Let's go with 7. Okay. 7. So this is 5y minus 3. Oh my goodness. If these aren't the same, we've done something wrong. Don't try to make them the same. If you get to the end and they aren't the same, you know you need to go back and figure out what you did wrong, okay? And we're left with our a, in this case it is my 5y minus 3, and my b plus some c, and this still needs to equal 0. Well, if this equals 0, then I found my solution, or if this equals 0, I found my solution. So let's say we're looking for what makes this equal 0, or what makes this equal 0. Well, to solve this equation, I need to add 3 and divide by 5, and I get y equals 3/5. And to solve this equation, I need to subtract 7 and divide by 2, and I get y equals negative 7 halves. Beautiful. We have just solved both of our equations. That was exhausting, but exciting. Now you can move on to your practice problems. So please take a second to, first you're going to be practicing 6 examples of factoring by grouping. Finally, there are 4 more examples of you applying the zero product property using factoring by grouping. Let me know if you have any questions, and I'll be around to see how you're doing.